Hi everyone, this is our MPMC project, electronic voting machine using 8251 microcontroller. Hi, I'm Deshwar.
Hello, myself Bhavesh.
Myself Arvind.
So the components required for the project is the 8051 microcontroller, which reads the button inputs and updates the LCD votes, LCD display, and here the push buttons, and there's also a reset button here, and we have a voltage regulator over here, which converts the 12 volt input into the 5 volt direct current, and there are 4 diodes which is used for rectifying the AC voltage from the adapter, and there are capacitors over there which are 1000 microfarad and 80 microfarad, which is used for filtering and stabilizing. So there is also a resistor which is used for the LCD contrast, and also there is a crystal oscillator present over here which provides the clock signals for accurate timing, and then there is also a LED which shows the circuit is powered on or is off, and it's all made over the PCB board.
When powered on, it displays its title and initializes the LCD. And we have 5 push buttons, 1, 2, 3, 4 and 5. One for start and other 4 for each political parties. One for DMK, ADMK, AAP and Congress. When the start button is pressed, voting begins. Each time a voter presses a party button, the party's vote count increments by 1 and it's shown in the LCD. The 8051 reads button inputs via port 3 and sends result to LCD via port 0. The system uses digital logic, delay generation and LCD interfacing techniques. It is a simple, reliable microcontroller-based voting system.
Now we are going to see the assembly programming language for the project electronic voting machine. First one, P0 equals to 80H, P2 equals to 0AH. This gives the name to SFR address P0, P2, P3 refer to the 8051 ports. Then this RS bit P2.7, RW bit P2.6. This defines the individual control signals for the LCD on port 2. Then button 1, button 2, button 3, there is a bit P3.0, P3.1 defines the 5 buttons input on port 3. Then this part DMK equals to 20, ADMK equals to 21, AAP equals to 23, Congress and etc. This gives the internal names to the internal RAM address 20 to 27H. These are used to store votes, count and temporaries. Then 00H and a small jump to main. This gives the reset. The CPU jumps to the label main org to place the address at 0. Then LCD command. LCD command move P0, A clears RS and clear RW. So this puts the byte on P0, clears RS and the RW, write the RW plus enable and calls delay to meet LCD timing, then clears enable and returns. LCD data. So this part, this is same as the LCD command, but it sets the RS is equal to 1 to indicate data instead of commands. So delay move R7, hashtag 200H, DL move R6, hashtag 255H. This is a 2-level nested loop producing a coarse delay used to meet LCD timing and to provide simple debouncing or time spacing. So write str WS loop. So this uses DPTR to point to 0 terminal RAM or ROM string. And see that move CA at DPTR. So reach the byte at DPTR. If it is 0, it will end. For each non-zero character, it calls LCD data to print increment DPTR loops. Now this line 1 move A, 80H. Add A, R0, A call LCD command. This builds the DRAM address for line 1. It adds the 08H to position in R0, then sends it to the LCD command. This line 2 does the same with base C0C0H. Then add it to the R0 and A call the command and return. So now this part is the most complex routine. It takes the numerical values and print a digit at a requested LCD line and position. So this display ADC move R0, R4, CJ NE R5 data L2, A call line 1 SJMP data clear. So DA line 2, A call line 2 clear to A call write STR. move R0, R4, CJNE R5, hashtag 1 DA L2W, A call line 1, SJMP DA ready. So this part explains that the R7 is equal to decimal number to display 0.255 in practice. R5 gives the line number. R4 gives the column or position on the line. The flow inside the display ABC is that move R0 to R4 to R0 and call line 1 or line 2 to position cursor, and then move DPTR which writes the two space to clear previous digits. Reposition cursor again to start where the digit should be printed. So this part DA ready move A R7 CJNE A at 10 hashtag 10, and this part checks if the R7 is less than 10. If it is less than 10, set DVSA is equal to 1, temperature is equal to 1. Else DVSA is equal to 10, temperature is equal to temporary is equal to 2, handled up to 2 digits. So basically this print loop move A R7 move A B DVS, this part performs the A divided B, then the quotient will be stored in A and the remainder will be stored in B. Now the holds the next most significant digit 0.09. So it converts the ASCII and writes it. So next the clear to dB, this clears the text used by display. Then this main initialization. A call delay move A hashtag 38H, A call LCD command move A 06H. These are the standard HT44780 LCD initialization sequence. This 38H function set is a function set. 06 is the entry mode. 0C is display on or cursor off, and 01 is the clear display. Then move dptr title hashtag title 1 a call write str. This part writes the strategic string that form the startup title and the voting UIE. For example, title 1, title 2 is electronic voting machine. Then SCR1, SCR2 gives the two-line layout showing DMK this number of votes, Congress this number of votes, AAP this number of votes, and ADMK this number of votes. So now we are entering to the main loop. So in the main loop, the jump button 1, main loop. So the button is check if the button 1 is pressed. If it's still 1, remains in the loop. When the button is pressed, the code waits for release, then sets flag is equal to 1. This implement a start or enable action. So again this flag check flag move A flag. So if the flag is 0, go back to the main loop. Voting is disabled. If 1, it proceeds to the check the third party buttons. So this segment checks if the each party button is turned in general pattern. The JNB button 2, DMK increment jumps to the DMK increment and the button 2 is 0. Otherwise jumps to the check other buttons. Wait DMK. This waits until the button is released. Increment DMK increments the DMK vote count in RAM. The new DMK value is loaded to R7, R5 and R4 are set to indicate line and position for display at ADC. Display ADC updates the LCD digit for the candidate. So clear flag disables the counting until button 1 is pressed again. SJMP main loop returns to the main loop. The same pattern repeats for ADMK, AAB and Congress. ADMK is button 3, AAP is button 4 and Congress is button 5. So we enter the final part of the code, which is the title 1 DB electronic voting 0 voting machine. These are the 0 terminal strings to store in the code memory and used by the write str. Then end of the code.